Section 5.2 is on functions, and our first definition is that a relation is a correspondence between a set of independent values called the domain and a set of dependent values called the range. We know that in any set, the independent values, if they're a set of ordered pairs, are going to be our x values, and the dependent values are going to be our y values. So if I want to list the domain and the range, for example A, the domain is going to be the set of all of the x values. So if I list the x values, they are -2, 2, 0, and 3. Now when I list these, I want to list them in numerical order. So I'm going to do -2, 0, 2, 3. And when my domain is a list like this, it's common to use curly brackets to enclose that list. Let's talk about the range. The range is a set of dependent variables, so in a list of ordered pairs, that would be the y values. And our y values are +3, +4, and -1. Once again, we want to list those in increasing order, so I'm going to say -1 first. -1 is in there twice, but I'm only going to list it one time. It's just the same number, so I'm listing all the unique numbers here. And once I have all my numbers listed, we'll enclose them in curly brackets, signifying that this is the set of numbers that is the range, and the set of numbers that is the domain. Let's look at part B. I'm going to use a capital D for domain instead of writing the whole word out. And our domain is a set of numbers like -2, 1, and 3. Those are all of the independent values. And our range is going to have 0, 5, 10, and 15. Let's look at part C. Now part C is given to us in a graph instead of a list. So when I read off the domain values, I'm reading off the x values of these ordered pairs. I can see that the x value for this dot right here is -5. The x value for the next one is -2. The x value for the third one is right there at 0 in the middle. I ran out of room, I'm going to write below it. The next one is 1. And the last one is 4. So there are 5 different x values in the domain. The range, the set of y values, there's only one y value, the y value 3, and all of those ordered pairs, so I was writing my bracket, 3, close my bracket, 3 is the only y value here. Every single one of these ordered pairs has a y value or a height value of 3. In part D, if we list our domain, the elements in the domain are going to be the words in this chart. So for example, it's going to be polar bear, cow, chimpanzee, giraffe, gorilla, kangaroo, and red fox. The range is going to be the set of numbers that those map to, in this case the age of the animal. Smallest number is 7, so we'll start with 7, then 10, 15, and 20. Okay, part E and part F. These are pictures again, similar to part C above, but they are continuous pictures where there aren't just a few dots. I'm actually including every single thing between these values. So I can't list all of these values. I can't list even all the numbers between 0 and 1. I can start at 0.1, 0.2, 0.3, 0.33, 0.335, 0.337. I could never get all the way to 1 by listing points. So we need to use an interval for the domain. There are a couple of ways to do this. So my domain, I can write my interval as an inequality. So I can say that the smallest x value is the x value -4, and the largest x value is the x value 4. So I could say it's all x's that are in between 4 and -4. I can express this as an inequality, x's that are greater than -4 and less than 4. Or I can express it in an interval using square brackets around the two numbers that are the end points of the interval. Using square brackets because we do include those numbers at the end. Sometimes an interval will have a parenthesis instead of a square bracket if the number at the end is not part of the interval. My range, let's look at height this time. So my smallest height value and my largest height value, my smallest height value is -2. So I could list this as -2 is less than or equal to y is less than or equal to 4 is the highest y value. Or I could list this as an interval, -2, 4 with those square brackets. As we move on into the next math class, we're going to be using interval notation more and more. So I'm going to circle the interval notation as the preferred notation for these. Let's look at part F, and we're going to write our domain and range in interval. First, the domain, looking at the smallest x value that the function hits to the largest x value that the function hits. The smallest x value, we always start smallest to largest in an interval. The smallest x value is -4. So bracket -4, comma, up until 5, close your bracket. For the range, the smallest y value the function hits and highest y value the function hits. Smallest y value is -4. Highest y value is +4. Let's look at the next page. Functions are a special type of relation where each member of the domain corresponds to exactly one member of the range. So for example, -2 is a domain member. It corresponds to 3 and only to 3. -2 does not correspond to any other value. So this is a function. In part B, if we look at the domain values, -3 corresponds to 2 and to nothing else. But when I get to these two ordered pairs, I've got a problem because 1, that domain value, is corresponding to both -2 and to 3. So this one is not a function because x equals 1 maps to both to, -2 and 3. The x value 1 repeats, another way of saying this. Let's look at part C. If you check out your independent variables, -3 doesn't map to two different y values, neither does 0, nor 1, nor 6, so this one's a function. And in part D, -2 maps to 0, nothing else. And again, we have a problem with 1. 1 is mapping both to 5 and to 10, so this is not a function. Once again, because the x value 1 repeats. Let's look at it in chart format. You can see in the input for part E, A is mapping to two different outputs, so this is not a function. So A repeats, or A has two outputs, another way of phrasing that. And then for part F, polar bear maps to 1, cow maps to 1. Each of these maps to just one output, so this one is a function. Let's go on to the next page. Consider the graph of the relation shown below. How can we determine from the graph that this relation is not a function? Okay, this is one that we already saw. We know that it is not a function because the 1 repeats. And let's just look at those ordered pairs. 1, 3, and 1, -2. It repeats, and how this shows up in the graph is that you have 2 points that are above or below each other, 2 points on the same vertical line. So if there are 2 points in the same vertical line, it's not a function. That brings us to the vertical line test. A relation is a function if and only if every vertical line intersects the graph once. If it intersects more than once, such as 2 times in the graph above, the graph is not a function. So let's look at these graphs and determine if the relations are functions. Imagine drawing any vertical line through this graph. It's only going to hit it once. It will never hit it twice, so this one is a function. In the next one, I can imagine drawing a couple of vertical lines that are going to be okay, but specifically there's a vertical line I could draw that's going to be bad. It's going to hit it in 2 places, so this one is not a function. If at any point a vertical line hits your graph in more than one place, the entire graph is not a function. Some more pictures to check out, determine whether the relations are functions. These are not lining up vertically, so these are okay. This is a function. In part B, a vertical line itself could never be a function because it's hitting itself in tons of places, way more than once. So this is not a function. In part C, You can imagine tons of different vertical lines, but they're all okay. They're never going to cross this more than once, so this is a function. Part D. Again, there are no points above or below other points, so this is a function. In part E, F, G, and H, the equations are written. We cannot see the graph, but I know what the graph looks like. What I know is that this is a increasing line, so I know that it has this shape to it. Anything that has a linear shape, an increasing line or a decreasing line, is a function. Alright, I don't know if the next line is increasing or decreasing, but I do know that it's a line. So regardless of whether it's a decreasing line or an increasing line, it is a function. In part G, the equation is y equals 42.25. Remember that an equation that has y solved for like this, no variables on x, does represent a horizontal line. This is the graph of a horizontal line. Horizontal lines will pass the vertical line test, so this is a function. And for part H, if the equation is of the form x equals a number, this is a vertical line. Vertical lines cannot be functions since they don't pass the vertical line test. They're going to have lots of dots along the vertical line. So this one is not a function. So some notes or conclusions. All diagonal and horizontal lines are functions, and all vertical lines are not functions. On the next page, we're going to determine whether the relation is a function. These are equations and graphs, so we can compare them. If the equation is y equals x squared minus 3x, the graph looks like this. And just imagining your vertical lines, they're going to be able to go through, no problem, so this one is a function. If the graph is the equation x equals 1/2 y squared minus 4, you can see right away that you're going to have some problems with vertical lines. This is not a function. Part C, if the equation is x minus 1 equals 1/4 y cubed, you can see that you can have tons of vertical lines that go through okay. This one is a function. Now if you're worried about this area right here, a vertical line can still pass through it once. It has a very, very steep slope, but it is changing. So this one does still pass the vertical line test. If I were to zoom in on this graph, I would see that it's getting really close and slides around, but it's never actually going to have 2 points up and down. It looks like it might here and here, but that's only because the pixel size is larger than the width of that ordered pair. So this does actually pass the vertical line test. It's a tricky one. But part D definitely does not pass it. You can see a variety of spots where it's going to fail the vertical line test. So this one is not a function for the equation y to the fourth equals 20x plus 80. So some conclusions we can gather from these. If you have an equation that is y equals x squared, or if you have an equation where y is to an odd power, it is a function. But if you have an equation that's x equals y squared, or something else where y is to an even power, it's not a function. So if y is ever raised to an even power, it's not a function. The odd powers were okay. The odd powers were still functions. Let's check out the next page. In example 6, I have some conditions here. A domain and a range are given, and I want to draw the function that has that domain. The first thing I'm going to do is kind of dot out where the x values and y values need to lie. The x values need to be between -2 and 5. So there's nothing to the right or to the left of those two lines I drew. And the y values need to be between -4, if I can draw a straight line, and 2. So everything I draw is going to be inside this little box right here to have the correct domain and range. The other thing is that it needs to hit some of those values. We want it to hit the value of 2 on x. we do not want it to hit the value of 5 on x because there is no equal bar underneath that inequality sign. So it's going to get very close to it, or we might have an open circle there instead of a closed circle. The same thing is going to happen with our y values. We do not want to hit -4, so we probably have an open circle there, but we do want to hit 2. There is a equal bar under that inequality, so we want that 2 to be included. Alright, so let's draw some of these things now. Your graph can look like a lot of different things. We're just going to draw one possibility. Okay, so this graph needs to go between -2 and 5. At the same time it's doing that, it's going to wiggle between -2 and 4. So I'm going to start my graph over here at some random point. This point has 2 on the x-axis, so I have a solid dot. And I just chose the height randomly. It can be anywhere you'd like along this height. And I'm going to wiggle this along, just trying to make sure that I connect between all of the y values that I need to have. You can wiggle as much or as little as you like. I'm going to say it needs to go up to a positive height of 2, including 2. So I'm going to just go right through 2, not stopping, and then down to a height of -4 before the end, and I'm going to put an open circle right there to signify that my graph is not allowed to actually touch that point because it cannot touch the value -4 on y, and it cannot touch the value 5 on x. Since this would correspond to 5, -4, we have an open circle there, and it gets really, really, really close because it connects all the way up until it gets to that dot. So just wiggles along, needs to connect through both the x direction and the y direction. Now we could go ahead and get rid of those pink lines that we drew, and you can see the graph of our function.